Hey everyone, welcome back. This is Professor Xiao. The purpose of this video is to help you with a specific homework question. The question is hands-on practice, so let's go to a Jupyter notebook. All the demos in this video is based on the dataset YOP1. This video may use some of these packages, especially RE for regular expression, GenSim, and scikit-learn. Note that I use the NumPy random seed 1 and random state 1. After reading the dataset, here is a high-level information about the dataset and the columns included. I printed the first 10 rows of the data by selecting a few columns. We will be focusing on the review text column of this dataset, which includes each of the review texts. The first review text, the second review text, and such and such. Each review text is referred to as a document. This is how NLP programmers refer to the texts, and the entire column of review text will be called a corpus. Now let's look at a specific problem. This video will focus on the symbol strings that we don't want. Those symbol strings were accidentally left in from the HTML data scraping, and I will demonstrate how to use regular expression to find and replace them. Let's look at a few examples of the review text to see our problems. This example has a symbol string that we don't want. We want to replace it. Take another sample. You see a similar symbol string here, but not much. Take another example, another symbol string, a few more symbol strings that are different from the examples that we saw earlier. Symbol strings like these will be the focus of this video. To see the scale of the problem, I will focus on two examples. One example is from this row of the data. You can see a few examples of symbol strings and they are somewhat different. This one is HTML tag, which was accidentally left into the data after data is crawled. We need to remove it without removing other meaningful texts. Another example I will focus on is from this row of the dataset. It has somewhat different symbol strings and we will deal with it. Here is a list of symbol strings that we will be dealing with in this video, as well as what they mean behind the HTML or XML codes. Even though you can use string literals to find these few examples and replace them in the data, this provides a good example to practice the usage of regular expression and to deepen your understanding about its power. Regular expression is by importing this package RE that is pre-installed in the Python installation. I have already imported this package on the top. The key to using regular expressions is to construct patterns, string patterns. The first pattern here is designed to take care of the first three examples of the symbol string. By observing the first three examples, you can see that they all begin with smaller than symbol, followed by letters or another symbol. They all end with a semicolon. You may also say that they all end with a group of symbols, ampersand GT semicolon. The GT stands for greater than symbol, which would be closing the bracket of the less than symbol in terms of HTML or XML tag, as explained here. So that is the pattern that we will construct by recognizing these commonalities of those examples. Pattern in regular expression is simply strings, but with special symbols to refer to repeated instances and symbol sets. So within the quotations, it's a string with special symbols. Every symbol outside the brackets are string literals. They will be matched exactly with the strings in the text that you search in. So I'm referring to the less than symbol, GT semicolon, except the asteroid symbol. The asteroid symbol is a special symbol. It has special meaning. I'll talk about that in a few seconds. Now let me talk a little about square bracket. Square bracket refers to a character set. You can construct the set whatever way you want. You can include individual punctuations, letters, numbers to include in a custom set, or you can use the dash notation to include a range of symbols, characters, numbers, or punctuations. But there's more than that. You can use a caret symbol placed at the beginning of the set of symbols inside the brackets. Remember, only the caret that is placed at the beginning of the list of symbols inside the brackets will be recognized as a complement. Caret can be used to refer to the complement set, which means whatever is included inside the brackets, the caret symbol will take the opposite set of it, the complement. So here, if I include a less than symbol inside the set and use a caret, that means I'm referring to any symbol, any letter, any character other than the less than symbol. So this set I am constructing has all the things, all the possible symbols except the less than. So this is a very large set. It only has one exception. Alright, so after understanding what the character set means and the caret, now I can talk a little about this asteroid. Asteroid symbol means that whatever is preceding this asteroid, it could be a single symbol or it can be a set. Here, the asteroid symbol follows a set, so that means this symbol is acting on the entire set preceding the symbol. This symbol means that whatever is before it can be repeated for 0 or 1 or more than 1 times infinitely, which means that this group here refers to any symbol other than the smaller than sign. Any symbol can be present for 0 times, for 1 times, or for infinite number of times between the less than symbol and the GT semicolon symbol. So this is the pattern that we're looking for. Here are a few examples that this symbol set can recognize. You can find some patterns from these examples. After I have defined the pattern, I will use this pattern to find the symbol strings instances from the motivate text example. Let's first examine this motivate text and see what symbol string examples we can find that will satisfy that pattern. I find 2 instances. The first one begins from here. A less than symbol and repeated symbols, which can be anything but the less than symbol again. There's no less than symbol here in this entire string, so everything will be selected all the way until the GT semicolon. So this part will be selected as the first instance and keep going. This is another instance of symbol string that will be matched by the first pattern. So let's run it and see if we're right. The result returned 2 instances exactly as we analyzed. Let's pause and think about a question. In the motivate text, one way to look at the matched instances is to include the text that will match the first instance of the ending part of the pattern. However, you can also go all the way until the last instance of the end of the pattern, like this. This set of characters will also satisfy the same pattern. It begins with the less than symbol and it ends with GT semicolon. How come the regular expression did not match this entire string and instead recognized 2 instances, first one being these and the second one being these? The question is why? A very good question. To answer this question, think very carefully and closely about the pattern again. Remember, one part of the pattern is the bracket, which refers to a character set. And in this character set, I specifically excluded a less than symbol. And that means as soon as regular expression found a less than symbol in the range of strings that may satisfy the pattern, it will discard the matched tail and reverse back to right before the found symbol that's supposed to be excluded and search for the tail again backward. As soon as it found this part of the strings that will match the ending part of the pattern, it will try to examine the range of strings again and see if it satisfies all parts of the pattern. And now it did not find a less than symbol inside this range of strings. So everything is satisfied. The pattern will return this first instance. The second instance is easy to recognize and it does satisfy all parts of the pattern. So this one is recognized. Now I hope that you understand why regular expression didn't select the entire range of string, but instead selected 2 instances and correctly recognized the symbol string that needs to be recognized and removed and replaced rather than over-selecting. Now let's use the same pattern to examine the sample text. In this sample text, I see a few instances of the symbol string that will satisfy pattern 1, such as these, and a few more examples like these. So let's run the code. These are all the instances of the symbol string that satisfy pattern 1. The demos I just did are used to examine if the pattern works. Obviously, the pattern works, at least for the 2 example texts. So now I will demo how to use a pattern to replace those instances that are recognized with something that you want being placed. The simplest and most intuitive replacement string would be a space, because you do want to keep the parts of the text before and after the found instances to be at least by a space apart, but you don't want to introduce any other potentially meaningful texts. That would be similar to changing the data. You don't want to do that. So there you go. You use a sub function of the regular expression package, and you provide the pattern, the replacement string, the text that you want the function to find the pattern and make the replacement, and an additional argument I will talk about in a few seconds. Let's run this. So the way to use the sub function is you can use sub without spelling out the argument name by providing the actual arguments in the correct order. The correct order of the arguments are use pattern to find symbol string and replace with the string you want in the string example with some options. And here is the string after replacement. As you can see, those 2 instances that were recognized earlier, as seen here, a long hyperlink tag and the ending tag, both of these instances have been replaced with space. They are supposed to be outside the bomb.com, and now it's gone. Perfect. A few words about argument. You can provide some options to be used to govern how the substitute, sub stands for substitute, how the sub function operates here. Sometimes your pattern has English letters and you would like the pattern to find not only the letters in that case that you provided, but also you want to recognize instances which contain the upper case of these letters. So in essence, if you don't care about the exact cases of the patterns in terms of those letters, you can specify that the function ignore the cases of those letters so that it will recognize all the instances regardless of the cases. You can do that by providing this argument. Regular expression ignore case. This is case sensitive. Provided to the flags, the sub function will ignore cases. Now let's run the substitution on sample text and assign it to sample text 1, which I will continue to develop examples using that. Let's run this. So after replacement, you no longer see the 4 tags, which are basically the line break tags in HTML code. The second kind of symbol string is like this. This one is pretty straightforward. There are no other symbol string instances that look similar to this one, so we will simply use string literal. The only thing to keep in mind is that the backslash is a special symbol. It's an escape symbol. You need to use another escape symbol to escape that in order for Python to recognize what you're referring to. And by looking at the original sample text 1, there are quite a few instances of this symbol string. So we should be able to find a bunch of them. Exactly, more than 10. So we'll use the same function, re-sub, to substitute the instances with a space in the sample text. Let's run this. After doing the substitution, the string becomes shorter, as you can see, and those instances of the symbol string has been replaced with a space. So there are multiple spaces in this string. The third and the last group of symbol strings have this pattern. Begins with an ampersand and maybe with an A most likely, ending with a semicolon, as can be seen here. The characters and punctuations and numbers between the beginning and ending may be different. This example has AMP semicolon and the pound key and 39. A few more examples of the 39 symbol. But in the entire dataset, there are other variations such as 34, another ampersand AMP, and MBSP, which is a space. So our pattern will pick up those symbol strings that begin with an ampersand. We can potentially recognize any letter with character set without including the A part, and with a semicolon. But it does have another semicolon inside the symbol set, so we want to allow that to happen for one time, for 0 times, or maybe for multiple times. But you can see that the only symbol that could not have been in between of the beginning and ending symbols would be another ampersand. So you can be quite sure that if regular expression examines a range of texts and it found another ampersand symbol between the beginning and the ending pattern, it can be pretty sure that it has included too much of the text. So it has to re-examine the end of the character range and to search another ending of the pattern. Let's focus on this pattern 3 and finding the instances in sample text 2 for now. Let's run this. So this function found 6 instances of this pattern. All of them are identical. This symbol in HTML actually refers to an apostrophe, like I am, I'm. It is, it's. One thing that you want to realize is that regular expression is very powerful. And when you deal with a large number of texts, a large corpus, you want to make sure that the patterns that you construct will not accidentally select texts that you do not want removed. So it is a rigorous process to routinely check the possibilities, all the instances that are selected by your pattern, to examine them thoroughly to make sure nothing unexpected will happen. That's the purpose of this line of code, along with other codes that I will paste here. The codes here look at the entire column of the review text in the Yelp data and accesses a method of this series object .string, and there is another method under the .string package which will help you find all the instances that fulfills this literal string pattern, and this method will be called on every element of the column so that you don't have to program a for loop explicitly, but you will get a column of results corresponding to each cell of the column. This function .find will return the index position of this string literal in the review text. For instance, if the review text begins with this symbol set, then the return value will be 0 because it's the beginning of the string. It has index position value of 0. If it does not find this string literal, it will return none, which is missing value. So I would only like to select those instances where this string literal is found. So I compare every value of the result to 0 or greater than 0 to mark those as true, the rows that this string literal has been found. So in the end, I get a true or false Boolean column in order to identify those rows of review text with this string literal found. After identifying those review texts that this string literal is found, I am ready to look at all the instances to examine, are there any symbol string that are unexpectedly selected by my pattern which I do not want removed. If there is none of those, then this pattern can be used safely. If there is, I will like to revise this pattern. So let me talk about these codes. It's quite deep here. The first line will construct a list of review texts. This is a list of review texts where the string literal is found beginning with ampersand. And what I do is I use the .lock method to select and slice those rows of the review text column that satisfy this condition. Remember, this is a Boolean indexer column. It will flag those rows that I have identified. Remember, only .lock method for slicing can accept a Boolean indexer. The .ilock cannot accept a Boolean indexer. So I get a list of review texts where the string literal is found. Next, I would like to do is to identify those instances that satisfy this pattern and extract them from the entire list. And the difficulty here is that certain elements of the review text list here may include multiple instances. So I will have a list that includes lists in it. I do not want those. I want to flatten all the nested lists and have a flat list. The trick to do that is to use list comprehension. Now the second line here will extract all those instances that satisfy pattern 3 from each element of this review text list. And because some of the result will be a list, so you have a list of potentially nested lists. So I have to do another list comprehension, and this time I need to loop 2 levels. The first level, for each item in the outer list, it potentially could be another list, right? So for each of these, I go through each of the element in that. So it's a nested list comprehension, 2 levels of for loop, if you will. If it's not a list, if it's a single item, that's fine. The program will treat it as a single item list, and this code will not break. In the end, I have a flattened list with all the instances found that satisfy the pattern 3. Then what I want to do is to leverage the series methods to do summary statistics as if they are categorical variable, right? I can calculate frequencies of each of the unique symbol set very quickly by using the series methods. So I turn this list into a series and I do the value count method, and let's run this. There you go. Of the entire column of the review text in the Yelp dataset, I have this many instances of this symbol, and over 3,000 instances of this symbol, and over 1,000 instances of that symbol. This is an ampersand. So now I'm quite sure that my pattern is good. Keep in mind that this pattern does include the AMP in it. So it will not select those symbol strings that begins with ampersand and followed by characters that are different from AMP. But we will examine that scenario and other scenarios in a second. And now I'm ready to replace the instances that are found by this pattern 3 with a space. Let's see what happens to this sample text 2. All those instances are gone, replaced with spaces. You do see excessive cases of spaces, but these spaces are very benign. They will be easily replaced and excluded when I talk about the tokenized task. As I said, you want to be very careful when you use regular expression. You want to thoroughly examine the scenarios where your pattern will select variations of symbol strings and rule out situations where it could unexpectedly select and remove text that you don't want removed. So here I'm doing that. I will construct a 4th pattern, not used to exclude anything, but it's used to examine all the cases that satisfy this pattern. The pattern is it will begin with ampersand and with semicolon. So this would be a pattern that will recognize all the variations that's possibly inside the review text that begins with ampersand. It will not find any other variations of symbol strings that do not begin with ampersand, but that's fine. I know that the set of symbol strings that begin with ampersand is the large majority in this Yelp review data. Pay attention to the character set that I constructed here. Inside the character set, I excluded these symbols from the set, or others can be allowed for 0 and multiple times of repetition. The symbols that I excluded included GT. GT is greater than. Remember that I already have a pattern that will recognize a symbol string that ends with GT. So whenever this pattern sees GT, that means a new symbol string that I want to exclude from this pattern. It also does include the semicolon. In these variations, semicolons are not allowed, which means it will try to find instances that were not found by pattern 3, and another ampersand, which is done similarly as in pattern 3. So I follow the same procedure to find all the instances and do a summary statistics. I apply pattern 4 to all the rows of this review text column, .apply, and here I use .apply because I'm not using a method that is available in the data frame or in the pandas package. I have to use lambda function to search for a pattern. and the result of the search will return a result or missing. I want all those that are not missing. So the end result of this for every row of that data is true or false. So by this, I constructed another Boolean indexer, similarly to the above example, but by using different functions. And this is the same process. I extracted all the text that pattern is identified. I extracted those symbol strings. I flattened the nested lists and put them into a series and use the series method to get statistics. There you go. Within the Yelp data, the only thing that will satisfy that pattern is an ampersand. By using pattern 3, I would have excluded the ampersand. To sum it up, I have developed 3 patterns to find 3 sets of symbol strings that I want removed, and now I want to clean the entire column of the review text, and this is the way to do that. It's like pipeline, but you are not putting together a single pipeline here. You're simply using 3 lines of code to process the data progressively by using the result that is the output of the previous step. I make a copy of the column so that I don't tamper with the original column. I use the .apply method and lambda function, again, which is necessary. By using these 3 lines of code, I would have cleaned the entire column of review text by removing all the instances that are identified by these patterns. And I have already examined that these patterns will do any unexpected damages to the data set. Let's run this. All right. As a last step of the sanity check, I will search for any symbol strings that begin with ampersand in the cleaned column of review text, just to see if there's anything remaining that needs to be cleaned. The result is no, I do not see anything being identified. The cleaning job is done beautifully. And the next job is to copy and add the cleaned text into the data set, and potentially maybe removing the original column of review text because it's already being cleaned and kept in a separate column. So I will make a copy of the original data set and copy the clean text into the text column. And because this is a new copy of the data set, I'm not tampering with the original data set. And simply take a sample and examine the cleaned text data. Do not see any unwanted symbol strings. Take another sample. Again, no symbol strings that we don't want. With that, it concludes the demo in this video. I hope you have enjoyed this video. See you next time.